as fresh water locked in ice sheets that have accumulated over millions of years. The continent sits alone at the bottom of our planet, isolated by the fiercest ocean currents and the most extreme weather on Earth. Here, temperatures plunge to -89 degrees Celsius. Winds scream across the ice at 200 kilometers per hour, and the sun disappears for months at a time during the endless polar night. But Antarctica was not always this way. Scientific evidence shows that long before humans walked the Earth, this frozen land was green and warm. Towering trees swayed in gentle breezes where now only wind howls across empty ice. Rivers flowed freely through valleys that today lie buried under kilometers of frozen water. Ancient creatures moved through lush forests that have since turned to stone, their fossilized remains waiting patiently beneath the ice like sleeping giants from another world. The story of Antarctica is a story of transformation, of a world that once was and a world that may be again. It is a tale of deep time, where millions of years pass like seasons and continents drift like clouds across the face of the Earth. In this frozen archive, nature has preserved clues to our planet's past and warnings about its future. Every layer of ice tells a story, every fossil whispers of ancient life, every hidden lake beneath the ice holds memories of a world we can barely imagine. Imagine standing on this endless expanse of white, knowing that beneath your feet lie the remains of tropical rainforests. Picture vast underground rivers flowing in eternal darkness, carrying water that has not seen sunlight for millions of years. Envision mountain ranges taller than the Alps, completely hidden beneath ice sheets so thick they could bury entire cities. This is Antarctica, a continent of contradictions where the hottest mysteries lie frozen in the coldest place on Earth. The ice here is not just frozen water, but a living record of Earth's history. In some places, it reaches depths of 4 kilometers, each layer marking another year in the planet's long story. Trapped within these layers are bubbles of ancient air, particles of volcanic ash from eruptions that happened millions of years ago, and dust from meteors that fell when dinosaurs still walked the Earth. Scientists who study these layers can read the climate like a book, discovering how warm or cold the planet was, what the air was like to breathe, and what life forms existed in ages past. Deep beneath the ice, in places no human has ever seen, lie valleys and mountains that have been frozen in time for millions of years. These hidden landscapes preserve ecosystems from when Antarctica was part of a supercontinent called Gondwana, when it sat closer to the equator and enjoyed a tropical climate. The trees that once grew there have turned to stone, their growth rings still visible after all these ages, telling stories of seasons that came and went when the world was young. As our world grows warmer, Antarctica's ancient secrets begin to stir. The ice that has protected these mysteries for so long starts to retreat, revealing glimpses of what lies beneath. Satellites capture images of strange formations emerging from the melting ice. Scientists drill deep into the frozen ground and discover things that challenge everything we thought we knew about life, time, and the history of our planet. What we discover there may change everything we thought we knew about Earth's history and our place within it. This is not just a story about ice and snow. It is a story about time itself, about how our planet breathes and changes over millions of years. It is about the delicate balance between warmth and cold, between life and extinction, between the known and the unknowable. Antarctica holds the keys to understanding how our world has changed before and how it might change again. The continent waits in silence, holding its secrets close. But slowly, inevitably, those secrets begin to whisper their truths to those who know how to listen. In Antarctica's stillness lies the memory of a world transformed, and perhaps the prophecy of a world yet to come. Every crack in the ice, every fossil discovered, every strange formation glimpsed through satellite imagery adds another piece to a puzzle that spans millions of years and may hold the key to our planet's future. This is the story of Antarctica's ancient warmth, its modern enigmas, and the uncertain future revealed as the ice begins to melt. It is a journey through deep time, where the past and future meet in the eternal present of ice and stone, where every discovery opens new questions and every answer reveals deeper mysteries waiting to be uncovered. Here, in the most remote and forbidding place on Earth, we find not emptiness, but abundance, not silence, but the echoes of a world that once was and may be again. 100 million years ago, Antarctica was not the frozen wasteland we know today. Scientific evidence from fossil records and geological studies confirms it was a land of towering trees, rushing rivers, and creatures that would seem impossible in the icebound continent we see now. To understand this transformation, we must journey back through deep time, to an era when the world was warmer and the continents were arranged in ways that would be unrecognizable to us today. During the Cretaceous period, roughly 100 million years ago, Antarctica was part of a massive supercontinent called Gondwana. This ancient landmass included what we now know as South America, Africa, Australia, India, and Antarctica, all joined together like pieces of a vast puzzle. But unlike today, Antarctica did not sit at the bottom of the world. It was positioned much closer to the equator, bathed in warm sunlight and blessed with a climate that supported lush rainforests and diverse ecosystems. Imagine walking through these ancient forests where the air would have been thick with humidity and the sounds of life. Giant tree ferns unfurled their fronds like green umbrellas, creating a canopy so dense that only dappled sunlight reached the forest floor. The trees themselves were magnificent specimens, some reaching heights of 40 meters or more, their trunks so wide that it would take several people holding hands to encircle them. These were not the hardy survivors clinging to life in harsh conditions, but thriving giants that had grown for centuries in perfect conditions. The evidence for this ancient green world lies frozen in the rocks and ice of modern Antarctica. Scientists have discovered fossilized tree trunks that once stood 40 meters tall, their growth rings still visible after all these millions of years. These rings tell a story of seasons that came and went in regular cycles, of years when growth was abundant and others when conditions were more challenging. Some of these fossil trees still stand upright, exactly as they were when they died, preserved in stone like ancient monuments to a world that no longer exists. But trees were not the only life forms that thrived in this green Antarctica. The fossil record reveals an astonishing diversity of plants, from delicate flowering species to massive conifers that would have dominated the landscape. Beech trees, similar to those found in temperate forests today, grew alongside ancient relatives of the monkey puzzle tree. Ferns of every size and shape carpeted the forest floor, while mosses and liverworts created soft, spongy cushions on fallen logs and rocky outcrops. The flowers that bloomed in this ancient world were not just beautiful but revolutionary. This was the age when flowering plants were first spreading across the earth, and Antarctica was one of the places where they flourished. Fossilized pollen grains, so small they can only be seen under powerful microscopes, have been found in rock layers throughout the continent. These tiny fossils tell us that Antarctica once bloomed with colors we can barely imagine as plants competed for the attention of insects and other pollinators. The rivers that flowed through these forests were not the seasonal streams we might expect, but permanent waterways that carved deep valleys through the landscape. These rivers carried sediment and nutrients from the highlands to the lowlands, creating rich deltas where even more diverse ecosystems could develop. Fish swam in these waters, and their fossilized remains tell us that the rivers were warm enough to support species that would be more at home in tropical climates today. Along the riverbanks and in the forest clearings, dinosaurs walked through landscapes that were green and alive. These were not the massive predators we might imagine, but smaller, more delicate creatures adapted to forest life. Some were plant eaters that browsed on the abundant vegetation, using their specialized teeth to strip leaves from branches and process the tough plant fibers. Others were small carnivores that hunted among the trees and undergrowth, their sharp claws and keen senses helping them catch prey in the dim light beneath the canopy. The seasons in this ancient Antarctica were unlike anything we experience today. Because the continent was positioned closer to the equator, the extremes of polar night and midnight sun did not exist. Instead, there were regular cycles of wet and dry seasons, warm and cool periods that allowed plants and animals to time their reproduction and migration. The growth rings in fossilized trees show us that these seasonal changes were predictable and stable, creating the kind of environment where complex ecosystems could develop and thrive. But perhaps the most remarkable aspect of this ancient world was its sheer abundance. The fossil record shows us that Antarctica was not just green, but teeming with life. Insects buzzed through the warm air, their fossilized remains preserved in ancient amber. Birds flew through the forest canopy, and while we have not found many of their bones, the presence of flowering plants suggests that there were creatures to pollinate them and spread their seeds. The soil beneath these ancient forests was rich and dark, built up over millions of years by the decay of fallen leaves and dead trees. This organic matter created a foundation that could support the massive root systems of the giant trees, while also providing nutrients for the countless smaller plants that filled every available niche. Fungi played a crucial role in this ecosystem, breaking down dead material and forming partnerships with tree roots that helped both organisms survive and thrive. The climate of this ancient Antarctica was remarkably stable. The global temperature was much warmer than today, and there were no ice caps at either pole. The atmosphere contained more carbon dioxide than our modern world, creating a greenhouse effect that kept the planet warm and humid. Weather patterns were different too, with gentle rains falling regularly throughout the year instead of the violent storms and extreme weather we might expect. The transformation from this green paradise to the frozen continent we know today did not happen overnight. It was a slow process that took millions of years, driven by forces so vast and powerful that they reshape entire continents. The key to understanding this change lies in the movement of the continents themselves, a process called continental drift. As Gondwana began to break apart approximately 140 million years ago, Antarctica slowly drifted southward toward its current position at the bottom of the world. This journey took millions of years, and as the continent moved, its climate gradually changed. The warm equatorial sun that had nourished the forests grew more distant, and the seasons became more extreme. But even more important than the continent's changing position was what happened in the oceans around it. When Antarctica was connected to other continents, warm ocean currents could flow freely around the world, distributing heat from the equator to the poles. These currents were like vast rivers of warm water that carried tropical heat to even the most distant regions of the planet. But as the continents separated, these currents were disrupted. The most crucial change came when Antarctica became completely isolated from the other continents around 34 million years ago, surrounded by the Southern Ocean. This isolation created what scientists call the circumpolar current, a massive stream of cold water that flows around Antarctica like a barrier, preventing warm water from the north from reaching the continent. This current is one of the most powerful forces in the world's oceans, moving more water than any other current system on Earth. It acts like a frozen moat, keeping Antarctica isolated from the warming influence of the tropical oceans. The cooling was gradual at first. The great forests slowly gave way to smaller trees and shrubs adapted to cooler conditions. Rivers that once flowed year-round began to freeze during the winter months. Snow that had once melted quickly in the spring began to accumulate, forming the first permanent ice fields. Over millions of years, these ice fields grew larger and thicker, eventually covering the entire continent in a frozen shell that would preserve the remains of the ancient green world beneath. The ice that formed was not just frozen water, but a complex archive of Earth's history. Each layer that accumulated told a story of the climate conditions when it was formed. Bubbles of ancient air became trapped in the ice, preserving samples of the atmosphere from millions of years ago. Dust and pollen from distant lands were buried in the accumulating snow, creating a record of what was happening around the world as Antarctica transformed from green to white. As the ice grew thicker, it began to flow under its own weight, creating the massive glaciers that we see today. These glaciers carved new valleys and shaped the landscape, but they also preserved the ancient forests by burying them so completely that they were protected from decay. In some places, the ice reached depths of 4 kilometers, creating a frozen tomb that would keep the secrets of the ancient world safe for millions of years. The animals that had once lived in the green Antarctica faced a choice as the climate changed. Some migrated to warmer lands, following the retreating forests northward. Others adapted to the changing conditions, developing thicker fur or different feeding habits, but many simply disappeared, their fossilized remains the only evidence that they ever existed. The final transformation took place over several million years, as the last patches of green vegetation were covered by advancing ice. The continent that had once been a cradle of life became a frozen monument to the power of geological change. But even in its frozen state, Antarctica continued to influence the world's climate, reflecting sunlight back into space and helping to regulate global temperatures. Today, scientists use sophisticated techniques to study these ancient ecosystems. They drill deep into the ice and rock, extracting cores that contain fossilized pollen, leaves, and even fragments of ancient wood. Chemical analysis of these samples can tell us about the temperature and humidity of the ancient climate, while microscopic examination reveals details about the plants and animals that once lived there. The story of Antarctica's transformation from green to white is more than just ancient history. It serves as a powerful reminder of how dramatically Earth's climate can change over long periods of time. The same forces that once turned a tropical paradise into a frozen wasteland are still at work today, and as our modern world grows warmer, we may be witnessing the beginning of another great transformation. Some scientists hypothesize that if current warming trends continue, Antarctica could eventually return to something resembling its ancient green state. The ice that has covered the continent for millions of years is already beginning to melt at an accelerating pace. As it retreats, it reveals glimpses of the ancient world beneath, like a time capsule slowly opening to reveal its secrets. What nature once buried, humanity may soon reveal. The secrets locked in ice for millions of years are beginning to thaw, and with them come new questions about our planet's past and future. In the fossilized remains of ancient forests, we find not just the story of what was, but perhaps a preview of what may be again. From space, Antarctica appears as a vast white canvas, unmarked by the complexities of civilization. But when satellites pass over certain regions of the continent, their cameras capture something that makes observers pause and wonder. Sharp angles emerge from the ice, geometric forms that seem almost too perfect to be natural. Pyramid-like peaks pierce through the frozen surface, their triangular faces catching the light in ways that stir the imagination and fuel countless questions. These mysterious formations have captured the attention of explorers, scientists, and curious minds around the world. In the remote Ellsworth Mountains, satellite images reveal peaks that rise from the ice in nearly perfect triangular shapes, their sides so symmetrical they appear to have been carved by some ancient hand. The shadows they cast create patterns that seem deliberate, mathematical, as if following some grand design that nature could not have created by chance. But appearances can be deceiving, especially when viewed from hundreds of kilometers above the Earth's surface. What looks like artificial construction from space often reveals itself to be something entirely different when examined up close. The pyramid-like peaks that have sparked so much speculation are, in fact, natural formations called nunataks, isolated mountain tops that protrude through the ice sheet like islands in a frozen sea. There is no scientific evidence supporting claims that these formations are artificial structures built by ancient civilizations or extraterrestrial visitors. These nunataks are the visible remnants of a much larger mountain range that lies buried beneath the ice. Over millions of years, as glaciers advanced and retreated across the continent, they carved and shaped the underlying rock into the forms we see today. The triangular shapes that appear so artificial are actually the result of natural processes, as erosion and weathering have sculpted the stone into these striking geometric patterns. The process that creates these formations is both simple and profound. As glaciers flow across the landscape, they act like massive rivers of ice, grinding away at the bedrock beneath. The ice carries with it rocks and debris, which act like sandpaper, wearing down the stone into smooth, angular surfaces. Over time, this erosion creates the sharp edges and flat faces that give these peaks their pyramid-like appearance. The forces involved in shaping these mountains are almost incomprehensible in their scale and duration. Imagine ice sheets several kilometers thick, moving with the slow but inexorable power of geological time. These glaciers have been grinding away at the bedrock for millions of years, each movement measured in centimeters per year, but accumulating over eons to create profound changes in the landscape. The rock that forms these mysterious peaks is ancient beyond human comprehension. Some of these formations are composed of stone that crystallized deep within the Earth billions of years ago, when our planet was still young and the continents were taking their first tentative shapes. This rock has witnessed the rise and fall of countless ecosystems, the formation and destruction of mountain ranges, and the slow dance of continents as they drifted across the face of the Earth. But understanding the natural origins of these formations does not diminish their power to inspire wonder. There is something deeply moving about these lonely peaks, standing like sentinels in the endless white expanse. They are reminders of the vast forces that have shaped our planet, monuments to the slow but relentless power of ice and time. In their stark beauty, they speak to something fundamental about the relationship between order and chaos, between the random forces of nature and the patterns that emerge from them. The human mind, it seems, is drawn to patterns and symmetry. We see faces in clouds, animals in rock formations, and ancient cities in natural landscapes. This tendency, known as pareidolia, is a fundamental part of how we process the world around us. When we look at the satellite images of Antarctica's strange peaks, our brains naturally search for familiar shapes and meaning, finding in the random patterns of erosion something that looks deliberate and planned. This psychological phenomenon becomes even more powerful when the landscape in question is as remote and mysterious as Antarctica. The continent's isolation and extreme conditions create a sense of otherworldliness that makes even the most mundane features seem extraordinary. When we cannot visit these places ourselves, when they exist only in grainy satellite images and scientific reports, our imaginations fill in the gaps with stories and possibilities that may be far more exciting than the reality. The terraces and ridges that mark the sides of these peaks add to their mysterious appearance. These horizontal lines, carved by centuries of freeze-thaw cycles, create patterns that look almost like the steps of some ancient structure. From above, they appear as regular as the stones of a pyramid, leading the eye upward toward the peak in a way that seems purposeful and designed. But these terraces are actually the result of a process called frost shattering, where water seeps into cracks in the rock and then freezes, expanding and breaking the stone apart. Over thousands of years, this process creates the stepped appearance that we see today. Each terrace represents a different level where the ice has worked its way into the stone, creating a natural staircase that climbs toward the sky. The cycle of freezing and thawing that creates these terraces is a daily occurrence in many parts of Antarctica. During the brief summer months when temperatures rise just enough to melt the surface ice, water trickles into the smallest cracks and crevices in the rock. When the temperature drops again, this water freezes and expands, exerting tremendous pressure on the surrounding stone. Over time, this relentless process breaks apart even the hardest granite, creating the stepped patterns that give these peaks their mysterious appearance. The shadows cast by these formations add another layer of mystery to their appearance. In the harsh light of the Antarctic sun, the angular faces of the peaks create sharp contrasts between light and dark, highlighting the geometric patterns in ways that make them seem almost artificial. The interplay of light and shadow creates an ever-changing display that can make the same peak look completely different depending on the time of day and the angle of the sun. During the Antarctic summer, when the sun circles the sky without setting, these shadows move in slow, hypnotic patterns around the peaks. The changing light reveals different aspects of the formations throughout the day, sometimes emphasizing their geometric nature, other times softening their edges and making them appear more organic. This constant transformation adds to the sense that these peaks are somehow alive, shifting and changing even as they stand frozen in time. Photography from space adds its own distortions to these already striking formations. The resolution of satellite images, while impressive, is not perfect, and the process of capturing and transmitting these images can create artifacts that make natural features appear even more mysterious. Compression algorithms and digital processing can sharpen edges and enhance contrasts in ways that make random patterns seem more deliberate than they really are. The technology used to capture these images is itself remarkable. Satellites orbiting hundreds of kilometers above the Earth must compensate for atmospheric distortion, the curvature of the planet, and their own movement through space to create the detailed images we see. The process of transforming raw sensor data into the photographs that capture our imagination involves numerous steps, each of which can introduce subtle changes that affect how we perceive these distant formations. The remoteness of these formations also contributes to their mystique. Unlike famous landmarks that can be visited and studied up close, these Antarctic peaks exist in a realm that is largely inaccessible to all but the most dedicated explorers and scientists. The extreme conditions, the vast distances, and the enormous costs involved in mounting expeditions to these regions mean that most of us will never see these formations except through the lens of satellite cameras. This distance creates a space where speculation can flourish. Without the ability to examine these features directly, without the mundane details that come from close observation, these peaks become blank canvases onto which we can project our deepest questions about the nature of our world. They become symbols of the unknown, representations of all the mysteries that still exist in our modern, well-mapped world. The few scientists who have managed to visit these remote peaks describe them as places of profound beauty and isolation. Standing at the base of these formations, surrounded by endless expanses of ice and snow, researchers report feeling a sense of awe that is difficult to capture in words. The silence is absolute, broken only by the occasional crack of shifting ice or the whisper of wind across the frozen landscape. Up close, the illusion of artificial construction often disappears. The rough texture of weathered rock, the irregular patterns of erosion, and the random placement of debris all reveal the natural processes at work. But even with this understanding, many visitors report that the formations retain their sense of mystery and wonder. There is something about their scale and isolation that transcends simple geological explanation. The appeal of these formations extends beyond their visual impact. They represent something fundamental about human nature, our desire to find meaning and purpose in the world around us. In an age when so much of our planet has been explored and catalogued, when satellite imagery can show us every corner of the Earth, these ambiguous shapes remind us that mystery still exists. They offer the possibility, however remote, that there might be more to our world than we currently understand. The scientific community approaches these formations with a mixture of fascination and caution. While researchers are confident in their understanding of the natural processes that create these shapes, they also recognize the importance of keeping an open mind about the mysteries that still exist in the world. The history of science is filled with examples of phenomena that were once considered impossible or supernatural, only to be later understood through careful observation and analysis. In the case of Antarctica's strange peaks, the scientific consensus is clear. These are natural formations created by well-understood geological processes. But this explanation does not diminish their power to inspire wonder and curiosity. If anything, understanding the natural forces that created these shapes makes them even more remarkable, revealing the incredible complexity and beauty that can emerge from simple physical processes acting over vast periods of time. The story of these formations also reflects our changing relationship with the natural world. In an earlier age, when much of the Earth remained unexplored, such mysterious shapes might have been attributed to supernatural forces or lost civilizations. Today, with our advanced understanding of geology and our ability to study even the most remote regions of the planet, we can appreciate these formations for what they truly are. Masterpieces of natural sculpture created by the slow but relentless forces that have shaped our planet for billions of years. Whether shaped by the hand of nature or the power of human imagination, these mysterious peaks serve as gateways to deeper questions about Antarctica and its secrets. They remind us that even in our modern world, there are still places that can capture our imagination and inspire us to look beyond the ordinary. In their stark beauty and geometric perfection, they invite us to consider the vast forces that have shaped our planet and continue to work beneath the ice, creating new mysteries for future generations to discover and explore. In the winter of 1938, as the world stood on the brink of war, a German expedition set sail for Antarctica. The ship Schwabenland carried with it a crew of scientists, aviators, and cartographers, along with equipment that would allow them to map vast areas of the continent from the air. Their official mission was scientific exploration and territorial mapping, but the timing and secrecy surrounding their journey would later fuel decades of speculation about what they truly discovered in the frozen wilderness. The expedition, known as the New Swabia Expedition, was led by Captain Alfred Richer and sponsored by the German government. The crew worked with remarkable efficiency, conducting aerial surveys of previously unexplored regions and dropping thousands of metal markers bearing the Nazi emblem to claim territory for the Third Reich. In just a few months, they mapped over 600,000 square kilometers of Antarctic coastline, taking more than 16,000 photographs that revealed features no human had ever seen before. But what made this expedition particularly intriguing to future generations was not just what they accomplished, but what happened to the knowledge they gathered. The outbreak of World War II meant that much of their scientific data was classified or lost in the chaos of conflict. The photographs they took, the maps they created, and the reports they filed disappeared into government archives, emerging only decades later to fuel speculation about what the Germans had really been looking for in Antarctica. The expedition's aircraft, specially modified seaplanes called Dornier-Wal flying boats, were launched from the ship using catapults and landed on the ocean surface to be recovered. These flights carried the explorers deep into the Antarctic interior, over landscapes that had never been photographed or mapped. The pilots reported vast mountain ranges, hidden valleys, and geological formations that seemed to defy conventional understanding of the continent's structure. Among the most intriguing discoveries were reports of ice-free areas, regions where the bedrock was exposed and the temperature seemed warmer than the surrounding frozen landscape. These areas, known as nunataks, were not unusual in themselves, but the size and extent of some of the formations the Germans reported were remarkable. Some accounts spoke of valleys that stretched for hundreds of kilometers, protected from the worst of the Antarctic weather by surrounding mountains. The expedition's cartographers worked tirelessly to document these discoveries, creating detailed maps that would not be made public for many years. The precision of their work was remarkable, considering the primitive navigation equipment available at the time. They used a combination of aerial photography, dead reckoning, and careful measurement to create charts that were accurate enough to be used by subsequent expeditions decades later. When the war ended, the fate of the expedition's leaders and their discoveries became a source of endless fascination. Captain Richer survived the war and continued his scientific work, but many of his colleagues were not so fortunate. The data they had collected was scattered across various archives, some falling into Allied hands, others disappearing entirely. This fragmentation of information created gaps that speculation would rush to fill. In the immediate post-war period, rumors began to circulate about what the Germans had really been doing in Antarctica. Some claimed that the expedition had been searching for a secret base where Nazi leaders could escape if the war went badly. Others suggested that they had discovered ancient artifacts or technological treasures hidden beneath the ice. These theories lack any credible evidence and have been widely debunked by historians and polar researchers. The reality was likely far more mundane. The German government, facing the prospect of global conflict, was interested in establishing territorial claims in Antarctica and gaining access to the continent's potential resources. The secrecy surrounding the expedition's true purpose, combined with the mysterious disappearance of so much of their data, created the perfect conditions for conspiracy theories to flourish. However, the expedition was part of a broader German strategy to expand their influence in remote regions of the world, similar to their activities in the Arctic and other unexplored territories. But the myth of the Nazi Antarctic expedition had taken on a life of its own, and it would soon be joined by another mysterious military operation that would add even more fuel to the fires of speculation. In 1946, just 1 year after the end of World War II, the United States Navy launched the largest military expedition ever sent to Antarctica. Operation High Jump, as it was officially known, involved over 4,000 personnel, 13 ships, and dozens of aircraft in what was described as a training exercise and scientific mission. The expedition was led by Admiral Richard Byrd, a legendary polar explorer who had already made his name with previous Antarctic expeditions. Byrd was a skilled aviator and navigator who had pioneered the use of aircraft in polar exploration. His reputation for meticulous planning and successful execution made him the natural choice to lead such an ambitious undertaking. The official goals of Operation High Jump were straightforward: to train military personnel in polar conditions, to test equipment in extreme environments, and to conduct scientific research. The expedition was planned to last 8 months, with teams establishing bases across the continent and conducting extensive mapping and research operations. The scale of the operation was unprecedented, involving more resources and personnel than any previous Antarctic expedition. But Operation High Jump ended abruptly after just 2 months, with the fleet returning to the United States much earlier than planned. The official explanation was that the mission had accomplished its objectives ahead of schedule and encountered harsh weather conditions that made further operations dangerous. However, the sudden termination of such a massive undertaking raised questions that would persist for decades among conspiracy theorists, though there is no credible evidence of any extraordinary discoveries that caused the early termination. Admiral Byrd's public statements after the expedition have been taken out of context and misrepresented by conspiracy theorists. In interviews with journalists, he spoke about the continent's potential resources and scientific importance, but many quotes attributed to him about lands beyond the pole or extraordinary discoveries have been fabricated or distorted. These false claims have been debunked by historians who have examined the original transcripts and recordings of his actual statements. The Admiral's actual statements focused on Antarctica's strategic importance for weather research and its potential mineral resources, both legitimate scientific and strategic concerns of the time. He emphasized the importance of international cooperation in Antarctic research and the need for continued scientific exploration of the continent. These legitimate statements, combined with the expedition's sudden termination, created a perfect storm of speculation. Researchers and conspiracy theorists began to connect the dots between the German expedition of 1938 and the American operation of 1946, suggesting the Americans had discovered evidence of German activities in Antarctica. However, there is no credible evidence supporting theories about secret bases or hidden technologies. The classification of much of Operation High Jump's records only added to the intrigue. While some scientific data was eventually made public, many of the expedition's reports remained classified for decades due to the Cold War context and military operational security concerns. The military aspects of the operation, including detailed accounts of what the various teams had encountered, were kept secret under standard military protocols rather than because of any extraordinary discoveries. The timing of these expeditions was particularly significant. The world was entering the Cold War era, and Antarctica's strategic importance was becoming increasingly apparent. The continent's potential as a military base, its possible mineral resources, and its value as a testing ground for new technologies made it a prize worth pursuing. Both the Soviet Union and the United States began to view Antarctica through the lens of geopolitical competition. The secrecy surrounding these expeditions created a perfect environment for alternative theories to develop. Without access to official records, researchers and amateur investigators began to piece together their own narratives based on fragmentary evidence, personal accounts, and educated speculation. The gaps in the official story were filled with increasingly elaborate theories about what had really happened in the frozen wilderness. Some researchers suggested that the expeditions had encountered evidence of ancient civilizations buried beneath the ice. Others proposed that they had discovered advanced technologies left behind by previous inhabitants of the continent. The most elaborate theories suggested that the expeditions had made contact with extraterrestrial visitors who had established bases in Antarctica's remote regions. None of these theories have any scientific evidence supporting them, and they have been consistently debunked by experts in polar history and archaeology. The psychological appeal of these theories was understandable. The idea that there were still great secrets to be discovered, That the world contained mysteries that governments and scientists were keeping from the public spoke to something fundamental about human curiosity and the desire for meaning. Antarctica, with its vast, unexplored regions and extreme conditions, seemed like the perfect place for such secrets to be hidden. The reality of these expeditions was likely far more prosaic than the myths that grew up around them. The German expedition was primarily a territorial and resource survey, conducted at a time when nations were scrambling to establish claims in unexplored regions. The American operation was a legitimate military training exercise and scientific mission, albeit one that may have been cut short by budget constraints, weather conditions, or political considerations. But the myths that surrounded these expeditions had a life of their own, and they would continue to grow and evolve over the decades that followed. The secrecy that surrounded so much of the polar exploration during this period created a fertile ground for speculation, and the extreme conditions of Antarctica made it seem like a place where anything might be possible. The legacy of these expeditions extends far beyond their original scientific and military objectives. They represent a turning point in humanity's relationship with Antarctica, marking the transition from purely exploratory missions to operations with strategic and political implications. The continent that had once been seen as a pristine wilderness was now viewed as a potential resource base and strategic asset. The stories that grew up around these expeditions also reflect the broader anxieties of the post-war period. The rapid pace of technological development, the emergence of new military threats, and the growing awareness of government secrecy created a climate in which conspiracy theories could flourish. Antarctica, with its remoteness and mystery, became a symbol of all the secrets that governments might be keeping from their citizens. Whether the truth about these expeditions was mundane or extraordinary, they had succeeded in establishing Antarctica as a place of mystery and intrigue in the popular imagination. The continent that had once been known only to a few hardy explorers was now the subject of widespread speculation and fascination. The seeds of doubt that had been planted by the secrecy surrounding these missions would continue to grow, shaping public perception of Antarctica for generations to come. Deep beneath the frozen surface of Antarctica lies a world that no human has ever seen directly, a realm of ancient lakes, towering mountain ranges, and ecosystems that scientists hypothesize have remained unchanged for millions of years. This hidden landscape, buried under kilometers of ice, represents one of the last great frontiers on Earth, a place where life may have found ways to survive in conditions that would seem impossible to most living things. The discovery of this subglacial world began in the 1970s, when scientists using radar and seismic equipment started to detect strange signals coming from beneath the ice. What they found challenged everything they thought they knew about Antarctica. Far from being a solid mass of frozen rock, the continent beneath the ice was revealed to be a complex landscape of valleys, ridges, and most remarkably, lakes of liquid water. The largest of these hidden lakes was discovered in 1996, buried beneath nearly 4 kilometers of ice in the heart of East Antarctica. Lake Vostok, as it came to be known, is roughly the size of Lake Ontario, stretching for more than 250 kilometers beneath the frozen surface. Scientists believe the lake has been isolated from the outside world for at least 15 million years, possibly much longer, creating a unique ecosystem that may have evolved in complete darkness and isolation. The very existence of liquid water so deep beneath the ice seems to defy logic. How can water remain unfrozen in a place where surface temperatures can drop to -80 degrees Celsius? The answer lies in the immense pressure created by the weight of the ice above and the geothermal heat rising from the Earth's core below. The ice sheet pressing down on the lake creates pressure equivalent to being 350 meters underwater, while volcanic activity and radioactive decay in the bedrock below provide just enough heat to keep the water from freezing. This combination of pressure and heat creates conditions that are both extreme and stable. The water in Lake Vostok is estimated to be at a temperature of -3 degrees Celsius, which would normally be frozen solid, but the pressure keeps it in a liquid state. The lake is also incredibly pure, with virtually no dissolved minerals or nutrients, creating an environment that would challenge even the most adaptable forms of life. But Lake Vostok is not alone in this hidden world. Scientists have now identified more than 400 subglacial lakes scattered across Antarctica, ranging from small ponds to vast inland seas. These lakes are connected by a network of rivers and streams that flow beneath the ice, creating a hidden hydrological system that rivals any found on the surface of the Earth. The discovery of this subglacial water system revolutionized our understanding of Antarctica's geology and ecology. The flowing water beneath the ice acts as a lubricant, affecting how the ice sheets move and behave. It also creates pathways for nutrients and microscopic life to travel across vast distances, potentially connecting isolated ecosystems that have been separated for millions of years. The mountains that rise from the floors of these hidden lakes are equally remarkable. Radar imaging has revealed peaks that tower more than 2 kilometers above the lake beds, creating underwater landscapes that would be breathtaking if they could be seen. These mountains are the remnants of ancient ranges that were formed when Antarctica was part of the supercontinent Gondwana, now preserved beneath the ice like monuments to a lost world. The valleys that wind between these subglacial mountains tell their own stories of the continent's past. Some are clearly carved by flowing water, with the characteristic U-shaped profiles of river valleys. Others show evidence of glacial erosion, suggesting that the ice sheets have advanced and retreated multiple times over the millions of years since Antarctica began to freeze. One of the most intriguing aspects of this hidden world is the possibility that it harbors life. The extreme conditions beneath the ice, with no sunlight, crushing pressure, and minimal nutrients, would seem to preclude any form of biological activity. Yet scientists hypothesize that microorganisms may have found ways to survive in these ancient lakes, adapting to conditions that would be lethal to most life forms. However, this remains largely unconfirmed due to the extreme difficulty of accessing these environments without contamination. The search for life in Antarctica's subglacial lakes has become one of the most exciting frontiers in modern biology. If organisms can survive in these extreme conditions, it would expand our understanding of the limits of life and provide insights into how life might exist on other worlds. The conditions beneath Antarctica's ice are remarkably similar to those believed to exist beneath the icy surfaces of Jupiter's moon Europa and Saturn's moon Enceladus. The challenges involved in studying these hidden ecosystems are immense. The lakes lie beneath kilometers of ice, in some of the most remote and hostile environments on Earth. Traditional drilling methods risk contaminating the pristine waters with surface bacteria and chemicals, potentially destroying the very ecosystems scientists are trying to study. New techniques have been developed to access these lakes without contamination, but the process remains extremely difficult and expensive. The few samples that have been obtained from the edges of these systems have yielded tantalizing clues about what might live in the depths. Ice cores drilled near Lake Vostok have contained traces of bacteria and other microorganisms that appear to be unlike anything found elsewhere on Earth. However, scientists remain cautious about these findings, as contamination from drilling equipment or surface organisms remains a significant concern in interpreting these results. Evidence suggests the presence of chemosynthetic bacteria, organisms that derive energy from chemical reactions rather than photosynthesis. These bacteria can use the minerals dissolved in the lake water or the heat from geothermal vents to power their biological processes. If such organisms exist in abundance beneath the ice, they could form the foundation of entire ecosystems that operate independently of the sun-powered food chains that dominate life on the surface. The isolation of these subglacial ecosystems has created unique evolutionary pressures that scientists hypothesize may have produced life forms found nowhere else on Earth. Cut off from the outside world for millions of years, any organisms that survived in these lakes would have had to adapt to increasingly extreme conditions as the ice sheets grew thicker and the environment became more isolated. The discovery of blood falls in the McMurdo Dry Valleys provides a dramatic example of how life can survive in Antarctica's hidden water systems. This striking red waterfall flows from beneath the Taylor Glacier, staining the ice with iron-rich water that has been trapped underground for millions of years. The red color comes from iron oxide, created by bacteria that have learned to use iron instead of oxygen in their metabolism. The water that feeds blood falls comes from a subglacial lake that has been isolated for at least 1.5 million years. Despite the extreme conditions, this ancient water system supports a thriving community of bacteria that have evolved unique strategies for survival. These organisms can survive in water that is 3 times saltier than the ocean, with no oxygen and temperatures well below freezing. The bacteria in blood falls represent just one confirmed example of how life can adapt to seemingly impossible conditions. Scientists believe that similar communities of extremophile organisms may exist in the much larger subglacial lakes scattered across Antarctica. These ecosystems could represent some of the oldest continuously inhabited environments on Earth, preserving forms of life that have remained unchanged for millions of years. The study of these hidden ecosystems has profound implications for our understanding of life in the universe. If organisms can survive in the extreme conditions beneath Antarctica's ice, it suggests that life might be possible in similar environments elsewhere in the solar system. The subsurface oceans of Europa, Enceladus, and other icy moons suddenly seem like much more promising places to search for extraterrestrial life. The techniques developed to study Antarctica's subglacial lakes are already being adapted for potential missions to these distant worlds. The challenges of drilling through ice, avoiding contamination, and detecting life in extreme environments are remarkably similar, whether the target is Lake Vostok or the hidden oceans of Europa. Antarctica has become a testing ground for the technologies and methods that may one day be used to search for life beyond Earth. The hidden world beneath Antarctica's ice represents more than just a scientific curiosity. It is a reminder of how much we still don't know about our own planet, and how life can find ways to survive in the most unlikely places. These ancient lakes and their possible inhabitants have been waiting in the darkness for millions of years, preserving secrets that could revolutionize our understanding of biology, geology, and the possibility of life elsewhere in the universe. The structure of these subglacial systems is as complex as any surface ecosystem. The lakes exist at different depths and temperatures, creating a variety of environmental niches where different types of organisms might thrive. Some lakes are shallow and relatively warm, heated by geothermal activity from below. Others are deep and cold, their waters barely above the freezing point despite the immense pressure. The chemistry of each lake is unique, determined by the type of bedrock beneath it and the minerals dissolved in the water over millions of years. Some lakes are rich in sulfur compounds, creating conditions that favor bacteria that use sulfur in their metabolism. Others contain high concentrations of methane, which could support different types of microorganisms. This chemical diversity means that each lake might harbor its own unique community of organisms, adapted to the specific conditions of their environment. The water in these lakes is constantly in motion, driven by temperature differences and the movement of the ice above. This circulation helps distribute nutrients and heat throughout the system, creating currents that could transport microorganisms across vast distances. The movement of water between lakes through underground channels means that organisms that evolved in one lake might eventually colonize others, spreading life throughout the entire subglacial network. Some of the most intriguing discoveries have come from the study of sediments on the lake floors. These ancient deposits contain clues about the history of the lakes and the conditions that existed when they were formed. Analysis of these sediments has revealed evidence of past climate changes, volcanic activity, and possibly even traces of ancient life forms that lived in the lakes millions of years ago. The geothermal activity that helps keep these lakes liquid also creates unique chemical environments that scientists hypothesize could support life. Volcanic vents on the lake floors release minerals and heat into the water, creating conditions similar to the deep-sea hydrothermal vents where life first evolved on Earth. These underwater hot springs could provide the energy and nutrients needed to support complex ecosystems, even in the absence of sunlight. The preservation of organic matter in these cold, isolated environments is remarkable. The low temperatures and lack of oxygen mean that any biological material that sinks to the lake floors could remain intact for millions of years. This creates a unique archive of ancient life that could provide insights into how organisms have evolved and adapted to extreme conditions over geological time scales. As the ice sheets begin to change in response to our warming world, the future of these hidden ecosystems becomes increasingly uncertain. The delicate balance of pressure and temperature that has kept these lakes liquid for millions of years could be disrupted by changes in the ice above. The ancient isolation that has protected these ecosystems could be broken, exposing them to contamination from the surface world. The race to understand Antarctica's subglacial world has taken on new urgency as scientists realize that these pristine environments may not remain unchanged forever. The secrets locked beneath the ice may soon be revealed not through careful scientific study, but through the uncontrolled melting of the ice sheets above. What lies beneath Antarctica's frozen surface may be one of the last great mysteries of our planet, waiting in the darkness to tell us stories of life, survival, and the incredible adaptability of living things in the most extreme environments on Earth. In the depths of the Cold War, as nuclear tensions reached their peak and the world teetered on the edge of destruction, something remarkable happened in Antarctica. On December 1, 1959, 12 nations came together to sign a document that would transform the frozen continent into a symbol of international cooperation and peaceful scientific endeavor. The Antarctic Treaty was unlike any agreement that had come before it, dedicating an entire continent to science and banning military activities in one of the most strategically important regions on Earth. The treaty was born from a recognition that Antarctica's unique environment and scientific value transcended national boundaries and political rivalries. The International Geophysical Year of 1957 to 1958 had demonstrated the incredible potential for collaborative research in Antarctica, with scientists from around the world working together despite the tensions that divided their home countries. The success of this cooperation convinced world leaders that Antarctica should remain a place of peace and scientific discovery. This unprecedented collaboration emerged from a period of remarkable scientific achievement. During the International Geophysical Year, research stations from 12 different nations operated simultaneously across Antarctica, sharing data and resources in ways that would have been unthinkable just a few years earlier. Soviet and American scientists worked side by side, trading information about ice core samples and weather patterns while their governments engaged in an increasingly dangerous arms race on the other side of the world. The 12 original signatories included the United States, the Soviet Union, Britain, France, Argentina, Chile, Australia, New Zealand, Norway, Belgium, Japan, and South Africa. These nations represented both sides of the Cold War divide, yet they found common ground in their commitment to preserving Antarctica for peaceful purposes. The treaty they signed would eventually grow to include 56 nations, making it one of the most successful international agreements in history. The provisions of the Antarctic Treaty were revolutionary for their time. The document declared that Antarctica would be used exclusively for peaceful purposes, prohibiting military bases, weapons testing, and nuclear explosions. It established freedom of scientific investigation and cooperation, ensuring that research findings would be shared openly among all nations. Perhaps most importantly, it froze all territorial claims to the continent, creating a unique legal framework that suspended national sovereignty in favor of international cooperation. The negotiations that led to this agreement were complex and delicate, requiring careful diplomacy to balance competing national interests. Argentina and Chile had overlapping territorial claims that extended deep into the Antarctic Peninsula. Britain, Australia, and New Zealand each claimed vast sectors of the continent based on historical exploration and geographic proximity. The United States and Soviet Union, while not making formal claims, reserved the right to do so and operated research stations throughout the continent. The genius of the Antarctic Treaty lay in its ability to set aside these competing claims without resolving them. Rather than trying to determine who rightfully owned which parts of Antarctica, the treaty simply declared that such questions were irrelevant for the purposes of scientific research and environmental protection. This approach allowed all parties to maintain their positions while agreeing to operate as if those positions did not matter. But the very success of the Antarctic Treaty in maintaining peace and secrecy around the continent's activities has, paradoxically, fueled decades of speculation about what might be hidden beneath the ice. The treaty's restrictions on access, while designed to protect the environment and maintain scientific integrity, have created an aura of mystery that conspiracy theorists have been eager to exploit. The fact that only approved scientific personnel are allowed to visit most of Antarctica has led some to wonder what authorities might be trying to hide. The treaty's provisions for environmental protection were strengthened over the decades with additional protocols and agreements. The Protocol on Environmental Protection to the Antarctic Treaty, signed in 1991, designated Antarctica as a natural reserve devoted to peace and science. This protocol banned all commercial mining activities and established strict environmental impact assessments for all activities on the continent. These environmental protections, while necessary for preserving Antarctica's pristine ecosystem, have also contributed to the sense that the continent is somehow off-limits to ordinary people. The complex permit processes, the expensive logistics required to reach Antarctica, and the strict controls on where visitors can go have created an atmosphere of exclusivity that feeds into conspiracy theories about secret activities and hidden discoveries. The bureaucratic machinery required to operate in Antarctica under the treaty system is genuinely complex and can appear mysterious to outsiders. Every scientific project must be approved by multiple national agencies and international bodies. Environmental impact assessments must be completed for even the smallest research activities. The movement of personnel and equipment is carefully tracked and regulated. This level of oversight, while necessary for protecting the continent's environment, creates multiple layers of administration that can seem opaque and secretive. The scientific research stations established under the treaty have become focal points for speculation about what might really be happening in Antarctica. These remote outposts, scattered across the continent's vast expanse, are often isolated for months at a time during the harsh winter months. The secrecy necessarily surrounding some military-funded research projects, combined with the extreme isolation of these bases, has created fertile ground for theories about classified discoveries and hidden agendas. The reality of life at these research stations is both more mundane and more extraordinary than most people imagine. The daily routine involves careful maintenance of life support systems, meticulous collection of scientific data, and constant vigilance against the harsh environment that surrounds these tiny outposts of human civilization. Yet the work being conducted at these stations is genuinely groundbreaking, involving everything from studies of ancient climate patterns to searches for life in extreme environments. The psychological impact of Antarctica's remoteness and harshness cannot be underestimated in understanding why conspiracy theories flourish around the continent. The extreme conditions, the months of darkness during polar winter, and the complete isolation from the outside world create an environment where reality can seem fluid and uncertain. Scientists and support staff who spend extended periods at Antarctic research stations often report strange psychological effects, including vivid dreams, altered perceptions, and a sense of disconnection from normal reality. These psychological effects are well documented in the scientific literature and are considered a normal part of the Antarctic experience. The combination of social isolation, sensory deprivation, and extreme environmental stress creates conditions that can profoundly affect human consciousness. Some researchers report enhanced creativity and insight, while others experience anxiety, depression, or difficulty distinguishing between waking and sleeping states. The phenomenon known as winter over syndrome affects many people who spend the dark Antarctic winter at research stations. As the sun disappears for months at a time, the lack of natural light disrupts normal sleep patterns and can lead to a condition similar to seasonal affective disorder. The small, isolated communities that form at research stations can become psychologically intense, with interpersonal dynamics taking on heightened importance in the absence of outside social contacts. These psychological effects, combined with the continent's otherworldly landscape and extreme conditions, have contributed to numerous reports of unusual phenomena over the years. Strange lights in the sky, unexplained sounds, and bizarre weather patterns have all been documented by Antarctic personnel. While most of these phenomena have logical scientific explanations, the isolation and stress of Antarctic life can make even ordinary events seem mysterious and significant. The classification of certain research projects conducted in Antarctica has also fueled speculation about what governments might be hiding. Military-funded research into topics like underground communications, extreme weather survival, and advanced materials testing is often classified for legitimate national security reasons. But the secrecy surrounding these projects has led some to speculate that they might be cover stories for more exotic research into topics like alien technology or ancient civilizations. The reality is that much of the classified research in Antarctica involves testing military equipment and personnel under extreme conditions. The continent provides a unique environment for studying how electronic systems perform in extreme cold, how personnel cope with isolation and stress, and how logistics systems function in remote locations. This research has obvious military applications but is generally far less exotic than conspiracy theorists imagine. The development of advanced technologies for Antarctic research has also contributed to conspiracy theories about the continent's secrets. The sophisticated equipment needed to operate in Antarctica's extreme conditions, including powerful radar systems, advanced drilling equipment, and specialized vehicles, can appear mysterious and ominous to those unfamiliar with their scientific purposes. Satellite images of these installations taken from space without context can fuel speculation about their true function. Some of the most advanced technology deployed in Antarctica involves ice-penetrating radar systems that can map the continent's subglacial topography in extraordinary detail. These systems are capable of detecting features beneath kilometers of ice, revealing hidden mountain ranges, valleys, and lakes that have been buried for millions of years. To those unfamiliar with the science involved, the capabilities of these systems can seem almost supernatural. The discovery of Antarctica's subglacial lakes and hidden ecosystems has added new dimensions to speculation about what might be hidden beneath the ice. The fact that these vast underground systems remained unknown for decades despite extensive research on the continent has led some to wonder what else might be concealed beneath the frozen surface. The extreme difficulty of accessing these subglacial environments has created an information vacuum that conspiracy theories have rushed to fill. The international cooperation required by the Antarctic Treaty has also created opportunities for misunderstanding and speculation. The fact that scientists from different countries work together on classified projects, sharing information and resources across national boundaries, can appear suspicious to those unfamiliar with the collaborative nature of Antarctic research. The complex web of international agreements and protocols that govern Antarctic activities can seem like a deliberate attempt to obscure the truth rather than a necessary framework for peaceful cooperation. The media's portrayal of Antarctica has also contributed to the atmosphere of mystery and speculation surrounding the continent. Popular culture has long depicted Antarctica as a place of hidden secrets and ancient mysteries, from the fictional city of the Elder Things in H.P. Lovecraft's stories to modern films about alien encounters and secret military bases. These fictional portrayals have influenced public perception of Antarctica, making the continent seem like a place where anything might be possible. The influence of science fiction on public perception of Antarctica cannot be understated. Stories of ancient civilizations buried beneath the ice, secret Nazi bases, and alien encounters have become so embedded in popular culture that they shape how many people think about the continent. When real scientific discoveries are announced, they are often interpreted through the lens of these fictional narratives, leading to misunderstandings about their true significance. The internet age has amplified these effects, allowing conspiracy theories about Antarctica to spread rapidly and evolve in real time. Online communities dedicated to uncovering supposed secrets about the continent have created echo chambers where speculation is treated as fact and scientific explanations are dismissed as cover-ups. The democratization of satellite imagery through platforms like Google Earth has given amateur investigators access to high-resolution images of Antarctica, leading to countless theories about unusual formations and structures. The very success of the Antarctic Treaty in maintaining peace and scientific cooperation has created a paradox that feeds into conspiracy theories. The fact that 56 nations can agree on anything, let alone maintain a decades-long commitment to peaceful cooperation in such a strategically important region, seems almost too good to be true to some observers. The treaty's effectiveness in preventing conflict and promoting scientific collaboration is so remarkable that it has led some to speculate that there must be some hidden agenda or secret knowledge that motivates such unprecedented cooperation. The scientific discoveries made in Antarctica have also contributed to speculation about the continent's secrets. The finding of ancient fossils, the detection of cosmic rays, and the discovery of new forms of life in extreme environments have all been genuine scientific achievements that have expanded our understanding of the world. But the announcement of these discoveries, often couched in careful scientific language and hedged with qualifications, can seem incomplete or deliberately obscured to those unfamiliar with the cautious nature of scientific communication. The logistics of Antarctic research have created additional opportunities for misunderstanding and speculation. The enormous costs involved in mounting Antarctic expeditions, the complex international coordination required, and the advanced technology needed to operate in extreme conditions have all contributed to the sense that something more than ordinary scientific research must be motivating these efforts. The fact that governments are willing to spend billions of dollars on Antarctic research has led some to speculate that there must be valuable resources or strategic advantages that justify such massive investments. The environmental challenges facing Antarctica have also become entangled with conspiracy theories about the continent's secrets. The melting of Antarctic ice sheets, the discovery of previously unknown ecosystems, and the potential for climate change to reveal long-hidden features of the continent have all created new opportunities for speculation. The urgency with which scientists are studying these changes has led some to wonder if there are particular discoveries or threats that authorities are concerned about but not revealing to the public. The future of the Antarctic treaty system faces new challenges as the continent's strategic importance continues to grow. The potential for mineral resources, the increasing accessibility of Antarctic waters due to climate change, and the growing interest of new nations in Antarctic research all create pressures that could test the treaty's effectiveness. The need to balance scientific research with environmental protection while maintaining the spirit of international cooperation that has made the treaty successful will require continued vigilance and adaptation. The legacy of the Antarctic Treaty extends far beyond the frozen continent itself. The agreement has served as a model for international cooperation in other contexts, demonstrating that even the most contentious political rivals can find common ground when faced with shared challenges and opportunities. The treaty's emphasis on open scientific collaboration and environmental protection has influenced the development of international law and diplomatic practice in numerous other areas. Understanding the real history and purpose of the Antarctic Treaty helps to dispel many of the conspiracy theories that have grown up around the continent. The treaty was not designed to hide secrets or protect mysterious discoveries, but rather to ensure that Antarctica remains a place of peace and scientific discovery for all humanity. The restrictions and protocols that govern access to the continent are not meant to conceal the truth, but to preserve one of the world's last great wildernesses for future generations. The story of the Antarctic Treaty is ultimately a story about human cooperation and the triumph of scientific curiosity over political rivalry. In a world often divided by conflict and competition, Antarctica stands as a testament to what can be achieved when nations commit to working together for the common good. The continent's secrets are not hidden conspiracies or ancient mysteries, but rather the ongoing discoveries of science and the remarkable story of international cooperation that has made those discoveries possible. The great ice sheets of Antarctica are melting. What began as subtle changes detected only by the most sensitive scientific instruments has accelerated into a transformation that is reshaping the continent at a pace that surprises even climate scientists. The ice that has covered Antarctica for millions of years is retreating, revealing landscapes that have been hidden since before humans walked the Earth. With each passing year, more of the continent's ancient secrets emerge from their frozen tomb, offering glimpses into both the distant past and the uncertain future of our planet. The scale of this transformation is difficult to comprehend. According to satellite measurements and scientific studies, the West Antarctic ice sheet, which contains enough water to raise global sea levels by more than 3 meters, is losing ice at a rate of 150 billion tons per year. The massive glaciers that have stood like frozen rivers for millennia are accelerating their flow toward the ocean, carrying with them the accumulated snow and ice of countless centuries. Satellite measurements show that the pace of this melting is not only continuing but accelerating. with ice loss rates doubling in some regions over the past 2 decades. But the melting of Antarctica's ice is not simply a story of loss. As the frozen layers retreat, they reveal a world that has been preserved in perfect detail for millions of years. Ancient forests emerge from the ice, their fossilized remains telling stories of climates and ecosystems that existed when the continent was green and warm. Mountain ranges that have been buried beneath kilometers of ice for so long that they appear on no maps are beginning to show their peaks above the frozen surface. The process of this revelation is both gradual and dramatic. In some areas, the ice retreats slowly, exposing new landscapes centimeter by centimeter, year by year. In others, massive ice shelves collapse in spectacular fashion, suddenly revealing thousands of square kilometers of previously hidden terrain. The Larsen ice shelf, which had been stable for thousands of years, disintegrated in a matter of days in 2002, exposing seafloor that had been in darkness since the last ice age. These newly exposed landscapes are not empty wastelands but complex ecosystems that have been waiting in suspended animation for their moment of awakening. The soil beneath the retreating ice contains organic matter that has been preserved in perfect condition for millions of years. Scientists have documented that seeds, spores, and other biological material that have been frozen in time begin to thaw and, in some documented cases, to grow. Scientists have discovered bacteria and other microorganisms that have remained dormant in the ice for hundreds of thousands of years, with some appearing to return to life as their frozen world begins to warm. However, researchers remain cautious about claims of ancient organisms reanimating, as distinguishing between ancient life and modern contamination remains extremely challenging. The implications of this biological awakening are profound and largely unknown. Scientists hypothesize that the ancient pathogens and microorganisms being released from the melting ice represent forms of life that evolved in completely different environmental conditions. Some of these organisms may be harmless relics of ancient ecosystems, while others could pose new challenges to modern life forms that have no evolved defenses against them. However, this remains highly speculative and extensive research is needed to understand these potential risks. The carbon locked in Antarctica's ice and permafrost represents another potentially significant factor in the continent's changing climate. As the ice melts and the ground thaws, scientists estimate that vast amounts of organic carbon that have been stored in frozen soil for millions of years are being released into the atmosphere. This carbon, in the form of methane and carbon dioxide, adds to the greenhouse gases that are driving global warming, creating a feedback loop that could accelerate the melting process even further. Scientists are particularly concerned about the methane trapped in Antarctica's ice. This potent greenhouse gas, which is more than 20 times more effective at trapping heat than carbon dioxide, has been accumulating in the ice for millions of years. As the ice melts, this methane is released into the atmosphere, where it contributes to the warming that causes even more ice to melt. The scale of methane release from Antarctica is still being studied, but some climate scientists warn that it could represent a significant addition to global greenhouse gas emissions. The retreat of Antarctica's ice is also revealing the continent's underlying geology in unprecedented detail. Mountain ranges that have been hidden beneath the ice for millions of years are beginning to emerge, showing landscapes that have been preserved exactly as they were when the ice first covered them. These exposed rocks contain valuable information about Antarctica's geological history, including evidence of past climate changes, volcanic activity, and the movement of continents over geological time. The discovery of previously unknown mountain ranges and valleys beneath the ice has revealed that Antarctica's topography is far more complex and varied than scientists had previously understood. Some of these hidden landscapes are below sea level, creating basins that could fill with water as the ice melts. Others are highland areas that could become islands or peninsulas as the ice retreats. The changing shape of the continent as the ice disappears is creating new geographical features that will need to be mapped and studied. The biological implications of Antarctica's changing climate extend far beyond the continent itself. The Southern Ocean, which surrounds Antarctica, is one of the most important ecosystems in the world, supporting vast populations of marine life that depend on the unique conditions created by the continent's ice. As the ice melts, it changes the temperature, salinity, and chemistry of the ocean, potentially disrupting food chains that have existed for millions of years. The krill that form the foundation of the Southern Ocean's food web are particularly vulnerable to these changes. These tiny crustaceans depend on the algae that grow on the underside of sea ice, and as the ice retreats, their food supply is threatened. Research has documented declining krill populations in some regions, which could have cascading effects throughout the ecosystem, affecting everything from penguins and seals to whales and fish. The changing conditions in Antarctica are also creating opportunities for new species to establish themselves on the continent. Plants and animals that were previously unable to survive in Antarctica's extreme conditions are beginning to colonize areas where the ice has retreated. Some of these newcomers are arriving naturally, carried by wind and ocean currents, while others are being inadvertently introduced by human activities. The invasion of non-native species represents a significant threat to Antarctica's unique ecosystems. The continent's native plants and animals have evolved in isolation for millions of years, developing unique adaptations to the extreme conditions. They have no natural defenses against invasive species that may be better adapted to the changing climate. Scientists warn that the introduction of even a single non-native species could have devastating effects on entire ecosystems. Current measurements show that the rate of change in Antarctica is accelerating beyond what most climate models had predicted. The continent's ice sheets are more sensitive to temperature changes than scientists had previously understood, and the feedback loops between melting ice, rising temperatures, and changing ocean currents are creating a system that is becoming increasingly unstable. What was once thought to be a gradual process that would take centuries is now happening in decades. The consequences of this rapid change extend far beyond Antarctica itself. The melting of the continent's ice sheets is contributing to rising sea levels around the world, threatening coastal communities and ecosystems on every continent. Scientists estimate that if current trends continue, sea levels could rise by several meters within the next century. The changes in ocean circulation caused by the influx of fresh water from melting ice could disrupt weather patterns globally, affecting agriculture, water supplies, and the distribution of storms and droughts. But perhaps the most profound implications of Antarctica's transformation are yet to be fully understood. The continent is entering a state that it has not experienced for millions of years, and the ecosystem that emerges from this transition will be unlike anything that has existed in recorded history. The interactions between newly exposed landscapes, changing climate conditions, and invasive species will create entirely new ecological relationships that scientists are only beginning to study. Some climate researchers hypothesize that Antarctica could eventually return to something resembling its ancient green state, with forests and grasslands covering areas that are now buried beneath kilometers of ice. This transformation would not happen overnight, but over thousands or tens of thousands of years as the climate continues to warm and the ice continues to retreat. However, this remains highly speculative, and the Antarctica of the future might be a continent of lakes, forests, and grasslands, supporting ecosystems that have not existed since the age of dinosaurs. The idea of a green Antarctica is not merely speculative. Evidence from the continent's geological record shows that it has supported lush ecosystems in the past, and the same geological processes that allowed life to flourish millions of years ago could theoretically do so again. The question is not whether Antarctica could become green again, but how quickly this transformation might occur and what form it might take. Current satellite monitoring and climate data indicate that the speed of change in Antarctica has caught many scientists off guard. The continent that was once considered the most stable and unchanging place on Earth is now one of the most dynamic, with new discoveries and dramatic changes occurring almost daily. Researchers who have spent their careers studying Antarctica are witnessing transformations that they never expected to see in their lifetimes. The monitoring of Antarctica's changing conditions has become one of the most important scientific endeavors of our time. Satellites, automated weather stations, and research bases across the continent are constantly collecting data on temperature, ice thickness, ocean conditions, and biological activity. This information is crucial for understanding not only what is happening in Antarctica, but also what these changes mean for the rest of the world. The story of Antarctica's transformation is ultimately a story about the interconnectedness of our planet's systems. The changes occurring in this remote continent are driven by global processes and will have global consequences. The ice that is melting in Antarctica fell as snow thousands of years ago, and the water that is being released will affect sea levels and weather patterns around the world for centuries to come. As we watch Antarctica's ancient secrets emerge from the melting ice, we are witnessing not just the end of one era but the beginning of another. The continent that has stood as a symbol of permanence and stability is showing us that even the most seemingly unchanging parts of our planet are in constant flux. The future of Antarctica, and indeed the future of our entire planet, depends on how we respond to the changes that are already underway and the choices we make in the years to come. Beneath ice, beneath myth, beneath the endless speculation and wonder, Antarctica holds truths far older than humanity itself, from ancient forests fossilized in stone to hypothesized ecosystems in unseen lakes that may have known no sunlight for millions of years, to valleys untouched since the world was young. This continent whispers of Earth's past and warns of its future. In Antarctica's silence lies more than mystery, more than fear. It holds the vastness of what we have yet to understand. We have journeyed through deep time, from the scientifically documented green world of 100 million years ago when dinosaurs walked through Antarctic rainforests, to the strange shapes that pierce the ice today, drawing our eyes and firing our imaginations with their natural geometric beauty. We have explored the expeditions that captured the world's attention and fueled decades of speculation, though we now understand that many of the most dramatic claims about these missions lack credible evidence. And we have descended into the hidden world beneath the ice, where scientists hypothesize that life may persist in conditions that would seem impossible to most living things. We have examined how the very success of international cooperation in Antarctica has created an atmosphere of mystery among those unfamiliar with scientific collaboration, and we have witnessed the continent's dramatic transformation as ancient ice gives way to reveal landscapes that have been waiting in darkness for millions of years. Through it all, Antarctica has served as a mirror, reflecting our deepest questions about the nature of our world and our place within it. The continent's final secret is not hidden in some undiscovered chamber beneath the ice, nor encoded in the strange patterns of its mountain peaks. It is not concealed in classified government documents or whispered in the corridors of research stations. Antarctica's ultimate truth is far simpler and far more profound than any conspiracy theory or ancient mystery. The secret lies in the very fact that Antarctica exists at all. In a universe of infinite space and countless worlds, we live on a planet that contains within its boundaries every extreme of climate and condition. From the tropical rainforests of the equator to the frozen wastes of the poles, Earth encompasses environments so diverse that they might as well be different worlds entirely. Antarctica represents the ultimate expression of this diversity, a place where the normal rules of life and survival are suspended, where the impossible becomes possible, and where the boundaries between science and wonder blur. The ancient forests that once covered Antarctica remind us that our planet is not a fixed and unchanging place, but a dynamic system in constant flux. The continents drift, the climate shifts, and life adapts in ways that would seem miraculous if we did not know they were real. The dinosaurs that once walked through Antarctic forests were as real as the penguins that inhabit its shores today, and the green world they inhabited was as much a part of Earth's history as the frozen continent we see now. The strange shapes that emerge from the ice teach us about the power of natural forces to create patterns that seem almost too perfect to be random. The pyramids and terraces carved by millions of years of erosion show us that nature is the ultimate architect, creating structures that dwarf anything humans have ever built. These formations remind us that our universe is governed by laws that produce both chaos and order, randomness and pattern in ways that we are only beginning to understand. The expeditions that have captured our imagination over the decades reveal as much about human nature as they do about Antarctica itself. Our desire to explore, to discover, to push beyond the boundaries of the known world is what makes us human. The mysteries that surround these expeditions reflect our need to find meaning and purpose in the unknown, to believe that there are still secrets waiting to be discovered in our increasingly mapped and measured world. Yet we must distinguish between legitimate scientific mysteries and unfounded speculation that lacks credible evidence. The hidden world beneath Antarctica's ice shows us that life is far more resilient and adaptable than we ever imagined. The bacteria that scientists hypothesize may thrive in the darkness of subglacial lakes, the ecosystems that may have survived in isolation for millions of years, and the ancient organisms that some research suggests might return to life after eons of dormancy all demonstrate that life finds a way to persist in even the most extreme conditions. These discoveries expand our understanding of what is possible and give us hope that life might exist in equally extreme environments elsewhere in the universe, though much of this remains to be confirmed through careful scientific study. The treaties and agreements that govern Antarctica demonstrate that humans are capable of remarkable cooperation when faced with shared challenges. The fact that 56 nations can agree to preserve an entire continent for peaceful purposes, and scientific research shows that we can transcend our political differences when we recognize our common humanity and shared destiny. Antarctica stands as proof that international cooperation is not only possible but essential for addressing the global challenges we face. The transformation that is currently reshaping Antarctica reminds us that we live in a time of unprecedented change. The ice that has covered the continent for millions of years is melting at rates that exceed even pessimistic scientific predictions, revealing landscapes that have been hidden since before humans existed. This transformation is not just a local phenomenon, but part of a global system of climate change that affects every corner of our planet. As we witness Antarctica's ancient secrets emerging from the melting ice, we are reminded that we are not separate from the natural world, but part of it. The carbon dioxide that is warming our planet and melting Antarctica's ice comes from our own activities, and the consequences of that melting will affect us all. The interconnectedness of Earth's systems means that nothing happens in isolation, and the changes occurring in Antarctica will ripple outward to touch every aspect of life on our planet. The stories we tell about Antarctica, from the scientific discoveries to the conspiracy theories, reflect our deepest hopes and fears about our world and our future. The continent serves as a canvas onto which we project our anxieties about climate change, our excitement about scientific discovery, and our wonder at the natural world. In the end, Antarctica's greatest secret may be that it shows us who we are and who we might become. The silence of Antarctica is not empty, but full, pregnant with the weight of deep time and the promise of discoveries yet to be made. In its frozen landscapes, we see both the permanence and the impermanence of our world. The ice that seems so solid and eternal is actually in constant motion, flowing like a frozen river toward the sea. The continent that appears so stable and unchanging is actually one of the most dynamic places on Earth, constantly reshaped by forces that operate on scales of time and space that dwarf human experience. As we reach the end of our journey through Antarctica's mysteries, we are left not with answers, but with a deeper appreciation for the questions themselves. The continent's secrets are not puzzles to be solved, but invitations to wonder, reminders that our world is far more complex and beautiful than we can ever fully comprehend. Antarctica teaches us that mystery is not something to be feared or dispelled, but embraced as an essential part of what makes life worth living, while always maintaining the crucial distinction between legitimate scientific mystery and unfounded speculation. In the end, Antarctica's final secret is that there are no final secrets, only an endless series of discoveries waiting to be made through careful observation, rigorous research, and scientific method. Each answer leads to new questions, each discovery opens new avenues of inquiry, and each mystery solved reveals new mysteries waiting to be explored. Antarctica reminds us that the universe is vast and full of wonders, and that we have only just begun to understand our place within it. The continent will continue to change, to reveal new secrets through scientific investigation and to challenge our understanding of what is possible. Future generations will walk on landscapes that are now buried beneath kilometers of ice, and they will discover things that we cannot even imagine through continued scientific research and exploration. Antarctica's story is far from over, and its greatest secrets may still be waiting to be revealed through the patient work of science. In Antarctica's stillness, we find not an ending but a beginning, not a conclusion but an invitation to continue exploring, questioning and wondering at the incredible complexity and beauty of our world. The continent that has captured our imagination for over a century will continue to inspire future generations, reminding us that there are still places on Earth where mystery and wonder await those brave enough to seek them out through legitimate scientific inquiry and evidence-based investigation.